power comes from you. Help us to use our knowledge to the welfare of mankind and society. We submit the entire program unto your hands. In Jesus' name we pray. Amen. Thank you, sir. Now over to Dr. Krishnamurthy for welcome address.
Thank you, Professor Colin, for the Bible reading and the opening prayer. I am very much privileged and greatly honored in welcoming you all. This is an auspicious day in the calendar of the Department of Physics, CSICE College of Engineering, KT UT. An year ago, during the month of June, we have organized a 3-day national level faculty development program on radiation and environmental radioactivity, which was a remarkably successful event. This is yet another occasion where the Department of Physics feels proud in organizing a national webinar on fundamentals of nanomaterials and its application to science and engineering on the 29th day of May 2021. On this occasion, I feel very happy to welcome our Bishop in Coimbatore, CSI Coimbatore Diocese, and the Chairman of CSI College of Engineering, KT UT, most respected Right Reverend Timothy Ravinder Ayya. Welcome you, Ayya. I also feel very happy to welcome our correspondent, Mr. Sudan Appadurai, who is a great inspiration to all of us. Welcome, sir. I take this opportunity to welcome our beloved principal, Dr. Joshua Segaran, who is the backbone of all successful activities.
Thank you, sir. Now we shall go for the guest speaker introduction. Dr. Natraj Sitaram has obtained a bachelor degree in civil engineering from Bhopal University, 1986. Master's degree, NIE, Mysore, in hydraulic and completed doctor's IISc, Bangalore, 1997. He has total 30 years of experience, in which 14 years in government sector and 16 years in teaching. He worked as a research engineer at Fluid Control Research Institute, Palakkad, National Transportation Planning and Research Center, Thiruvananthapuram, and MACT Bhopal, now it is MANIT. He worked as a professor and head of the department and principal at various institutions. Currently, he is a professor and head of Department of Civil Engineering, East Point College of Engineering, Bangalore. His achievements: he has received the UNICEF Best Paper Award at MNIT Jaipur. He has completed 20 sponsored research projects: IGCAR Kalpakam, Bell Bhopal, Jyoti Limited Baroda, KPCL Bangalore, Karnataka Urban Water Supply and Drainage Board, NPOL Kochi, King Abdulaziz City for Science and Technology, Riyadh, Saudi Arabia, and BRNS, Mumbai. His research interest includes use of nanomaterials in construction technology for fire resistant and acoustic performance, computational dynamics CFD, hydro turbine testing, backwater hydrographic survey, and water saving devices. We are very, very privileged to have you here, sir, this morning. Thank you so much. And I give the rest of the time for the full-fledged knowledge flow to the guest speaker. We welcome you, sir, and we please have the entire program at your hands.
Okay, thank you very much for introducing me, madam. Respected chairman of the institute, CSI College of Engineering, principal, other faculty colleagues. First, I would like to thank our principal, Dr. Prakash, East Point College of Engineering, our chairman, Dr. Rajiv Gowda, who has allowed me to share the knowledge with you, all my faculty friends, my students from EPCET, your college, and my friends distance at Madhya Pradesh, Maharashtra, and other places. My dear friend, the nano science or nano engineering is one of the emerging area in the research. I know that many of our faculty members are working in this, but please excuse me if I become slightly slow and explain the basic concepts to the student level so that they can take up some challenging projects. Okay, so I'll start with that. Hopefully, my flow will be slow, so don't mistake me. To start with, he is the person, Richard Feynman, you can see in 1959. He is the person who talked about this nano material. You might have heard nano car, isn't it? Similarly, nano means what? Nano means normally 10 to power minus 9 or even smaller than that. We would like to know what is this small material which influences the property of a chemical or a gas or a material in such a way it is useful to the humankind, as in the prayer they mentioned. Definitely, God is giving us so many good things to utilize for the benefit of our society. So nano is also one of the wonderful thing which has come into existence. All salutations to Richard Feynman. He is the person who introduced this material. He says at the bottom. Bottom means the material is small. Question is why nano? Okay, I'll come to that later. Let us see one more thing. I hope my fundamental injection is clear. This material is going to give us an edge over all the existing material for their performance. The performance could be strength, performance could be identifying the cancer, performance could be cleaning the water, anything, any application. In the COVID also they are being used. Anyway, I'll come to that one by one. So my fundamental point is very clear. Okay, it's a small material. Let us see the different area of application. I think, as our friend said, it's a science and engineering, even medicine, everywhere it is applicable. You can see the list is even more than space application also is being used now. Yesterday I was reading in the Google News, brain damage or hemorrhage is there. It is able to correct those things. Fantastic thing. Anyway, you may be thinking I am basically a hydraulics man, but recently I shifted my focus to this one. One PhD student is working under me. I'll come to that later. You can see these are the different various phases where this material can be used for the benefit of the material and society. It can be engineering science, it could be architecture, it could be solid state physics, chemistry, crystallography, tradition, anything, metallurgy. Right? Nanomaterials have been applied even defense sector, in automotive sector, everywhere nowadays the performance is required, whether I am teaching a subject online or offline. Always the students will be looking how I am conveying the message, right? So one thing is very clear, it's a small material and it has got a lot of dimensions. We say 1D, 2D, 3D, no, it's a multi-dimensional where we are going to use this. Is it okay? So I have conveyed you two important points, right? Now the question comes, nano comes from the Greek word. It says very low height, a small size. I think I have shown the size meter. It's I think 100 centimeter, then decimeter, centimeter, 1 centimeter, 10 mm, right? 100 centimeter is 1 meter. Then we have millimeter, we have micrometer, we have a the scale is getting down. I am going slowly towards a smaller particle. Okay, so I have given you an idea. Nanoparticle is important, application in every dimension, and its size is very, very small, right? Okay, you can see 1 nanometer I have mentioned, 10 to power minus 9 meter, even it can go even lesser than this. Let us see one more thing. A man's hair grows 5 nanometer every second. A human fingernail grows 1 nanometer. Nano is natural in the plants, in the fly, as well as it is manufactured by the mankind. You can see here 1 inch is around 254 million nanometer. Okay, 1 inch is there in my hand, this much. Okay, you can say that it will contain 254 million nanometer particles in that. Definitely, one thing is very clear, it is very, very less in size, and no doubt it will be costly also. I will talk to that later. Very small. Okay, now let us see one more slide. What is the advantage of the nanometer? What is the advantage of nanometer? With permission, shall I stop the video? Is it okay? Krishnamurthy sir, is it okay?
Please go ahead, sir, as you wish.
Right.
Thank you.
Nanomaterials, small sizes, it has got some volume, maybe nanometer cube. You can see the surface area is very big. We have some process which needs more surface area. It can be even diffusion, it can be even dispersion, it can be even absorption. All these things are very good in nanometer. You can see even size of 200 nanometer, how much is the surface area. Very, very advantageous. Okay, I'll come to that later. How it changes the characteristics of a material when it is involved in small percentage. Okay, I repeat again, nanomaterial has got an advantage that it has more surface area when it gets mixed into the system, or you can say the material, the chemical, whatever it is. So it is offering you more surface area. Okay, let me see. Okay, sir, it's having more surface area. What is the advantage? I'll come to that. Okay, next one you can see. It's not moving. Is it moving? Yeah. Now, in the world, there was a discussion. Okay, can it help us? The question is, can it help us? That is one thing. Nanotechnology inside. Is it dangerous? Number one. How it is responsible to be used? How it can be applied to the different challenging medical domain, maybe automobile domain, maybe space domain, maybe even cleaning of air. How we can apply this? Example I have given you, a dirty water is there and there is a filter and a clean water is coming. Concept is good. We say that nanotechnology is there. Then what is this nanotechnology? Okay, nanomaterial is okay. Nanomaterial is a small material, as I mentioned earlier slides. Now we want to talk about technology. I'll come to that again. So one thing is very clear, people are questioning now. Can it be useful? Can it be applied any other? Can it have a magnetic property? Can it have any magnetic property to useful? Or can I plan it such a way it changes its characteristics with time? For example, I'm basically a civil engineer, as I mentioned. Whether the building can be red when it is hot whether the building can be blue when it is cold or yellow when it is ordinary. Is it possible to have? Answer is yes. These nanoparticles are able to even extract heat from the buildings. Anyway, we'll go to the next one. So now questions are being asked. Now we come to our practical physics or practical engineering. Material without nanoparticle. It may be breakable. It can be inflexible, less durable. I am very sure that in the Ooty or in Trivandrum or in Bengaluru, if there is a high wind, all our trees, even grass, will deflect a little bit and come back. That flexibility is required in a building. That flexibility is required in a material when it is subjected to high pressures or high impact loadings. Can it take? It means I am thinking, can I stop tsunami near the coastal area when it comes and I am safe in my house? Is it possible? Let us think that. Complex issues are there and we have a limited application. You know very well that pappadam is there, no? It is able to break very easily because it is brittle. Can we make it flexible like a bread? Can I make it flexible like a elastic so that it will expand when the pressure comes and it comes back when the pressure goes off? I repeat, we are needing now the material, whether it's a defense material, whether it's an automobile, whether it's you can say flood resistant buildings, we need some material which are flexible in nature. Can I bring it back? Taiwan is well ahead of this. Taiwan is giving buildings with earthquake resistant buildings. If the Richter scale of even 5.8, 5.9, the buildings are intact. Great. Okay, let's see. Now understood, one thing is very clear. Now, these materials are very useful, maybe in textile. I hope you can see this here. There is a t-shirt which is not going to be soiled even if I'm using for 2 weeks, 3 weeks. Why? Because nanoparticles will take off that. Similarly, the buildings will retain its shine. Similarly, any material which we are talking, which is used by the human society, maybe a mobile phone, maybe you can say roads, maybe anything you can say, maybe even chip, maybe a computer, anything, that can do something extraordinary from this. So one thing is very clear, it's a magic man. You can see from the smile. It's a magic man which can change its properties with time. It can change its behavior with time. It can be replaced very easily. It is durable also. So one thing very clear, it's a more durable. We can design our property. We can put high performance. We have a flexible. Okay. Okay, sir, we understood that this is a small material applied to all the field, even including the clothes also, jeans also, right? We would like to apply. Definitely, you can see the design. That's the reason I mentioned. It is basically the science and engineering both, and the humanity. Physics, chemistry, the biology, all the three together. And this material is having a common place for that, which is called nanomaterial. Is it okay? It's a power technology. How it can be used for good, we will see. Could it be accidentally chosen? Could it be again framed with some? Can I design nanomaterial? My question is that. I'll come to that. So I think till now whatever I told is very clear, my students, that nanomaterial is useful. Nanomaterial can be applied where the materials have a limited performance. I can extend their domain to the environment, to the fatigue condition, to the impact condition. Right. Let's see next. You can see a flexible structure. Can you see like a button? I don't know whether. Ma'am, is it visible?
Yes, sir, it is visible. Yes.
Animation is there, no, ma'am? Okay.
Yes, sir. Yes, we can see the animation.
Structures, you can see the change shape and color. Okay.
Yeah,
Definitely
color
we have
pixels
chameleon. No?
change. Yes, sir.
Yeah, thank you. Now, I would like to know what are the challenges we have when we talk about this kind of technology. Go back. Okay. We can extract mechanical properties from nano. Now I am coming slightly to the technical part. Okay. I can extract some mechanical properties from this. I can extract some chemical properties from this. Extract means it can be tailor-made. It can be designed. Okay. It can be optical based. It can be magnetic. It can be having the stereo rotation, and it can show even super paramagnetism behavior, the material, the electrical based. It can get even metal oxide, like MnO2 and all. It is really important for batteries for cars. It is very important for high strength materials of, you can say, buildings, or even you can say bunkers, which we are making for the defense purpose. It can be used for optical fiber communication. It can be used for magnetic fluid system. Definitely we are having something God made nanomaterial as well as the manufactured material. They are giving an extra hand. Normally in Hindu system they show God has got 4-5 hand. Kali Mata will be having 4-5 hand. So instead of 2, one more hand has come from the nature. That is a nanomaterial. Okay. Let us see how it is important, how the things are man-made. You can see a plane to a small pin. We need material. Okay, even insects. Okay, they also do lot of chemical changes in the soil system. They also changes lot of system in the plant system. Definitely, we can get lot of information from this. Anyway, I am not a biologist about, but I am telling there are many useful things are coming from the nature. Then we have a types of nanomaterial. It could be organic nanoparticles, it could be hybrid, or it could be inorganic. Okay. I am right now working on the inorganic. I'll come to my research later. Carbon nanotubes are very important. Gold shells. Many old paintings we can restore with the help of nanomaterial. It can reflect the same. I have seen this Bhimbetka. There is a place in Bhopal where the color in the caves they have color painting is there since 1,000 years. Maybe some nanomaterial matter they have used. Even Ajanta Ellora you might have seen. There are some color paintings are there. Till today it is available. We can go and see really wonderful things. Okay, the God is giving us so many hints to learn from the nature. We need to learn from that. So definitely everyday object we can have the use of nanomaterial. Now question I raise, okay sir, you talked about the nanomaterial, very nice. How novel are the properties? One is the reactivity, one is the size itself. It can mix it so nicely, no harm, it is durable, it can be used in electronic gadgets, it can be used at discrete energy levels. You can see I showed you a small animation of nano wave guide. Definitely in any static system, semi-dynamic and dynamic system, these materials can be used. You may be thinking, what is that material which is subjected to dynamic system? Like our rail track, rail wheel. Continuously it will be running from Bangalore to Delhi, or you can say Coimbatore to New Delhi, or even Jammu Kashmir. You just think of those material which is running on the rail track. Definitely we need very less deterioration of such materials. That can be there. Similarly, the track also, it should be there. Our Madras Delhi track is so old. All these things, they demand some durability of materials. We can do research in this particular area. Magnetism is also another area which is doing magnetic nanoparticle. They are very, very useful for pollutions. I think ESP you might have heard, electrostatic precipitators. Anybody is having any idea? It is basically the chimneys where the ash is going or any gases are going to the atmosphere. We can arrest those materials by putting this nano filter using an ESP. It can be a polymer, it could be a three-dimensional scaffolds, it could be any important material which is having very good trap efficiency on these ESPs can be used. We call electrostatic precipitator because it has got some static electric charge on that, because surface tension forces are dominating in the chimneys, right? I had done a small work on that. Anyway, it's beyond the scope now. Now, now we have understood, sir. Okay, sir, we have understood.
பாய்டா மகன்.
Hello, sir. Hello, sir.
Yes, you're audible, sir. You're audible, sir.
Whether this
Yes, sir.
slide was over?
Yeah, it is now the nanomaterials and nanotechnology, the growth of nanomaterials.
Okay, no, it's okay, no.
Yes.
Here?
Yes, sir. Slides are
Okay,
okay,
okay.
sir.
I'll
Slides are
continue.
okay. Please, please.
Thank you for reminding me.
Thank you, sir.
I'm not going fast, no, sir.
No, sir, you're on the mode, normal mode.
Right. Thank you.
Please.
Now, my dear friends, we would like to now see nanomaterial either in the form of a rod or in the form of a particle, or it can be in the form of coating. as I mentioned, the coating is something we are using for protecting it from the environment. Normally, it is used for metals, alloys, ceramics, composites. Okay. Now, the development of material and devices by exploiting the characteristics of this small material is called nanotechnology. Okay, we would like to develop this material for our use. My dear friend, sorry. Now, types, if you go, we have these types of material like silicon dioxide, titanium dioxide, zinc oxide. We have nanosilica, also one of the commonly used in civil engineering. Aluminum oxide I have already used. Silver nanoparticles are a bit costly. Zirconium oxide nanoparticle also has got excellent thermal characteristics. Aluminum oxide, the name is aluminum is very famous for stability. So these nanoparticles are ductile in nature. It will increase the ductility of metals. Then we have tungsten. These are very good. We have scandium crystal animation, like smart sensors are available, which are giving you the deformation with the load you apply. Carbon composites are also equally important. Normally, they are coming either in multi-walled or single-walled. We are now using multi-carbon nanotubes, MCNT, and also using for our applications. I'll come to that later. Apart from this, there are two more terms. This are taken from IISc. I thank Institute of Science. They have got a separate center for the nano material. They say nano composites. These nano composites, they enhance the performance. There is one more term called nanoporous material. Very nice. It is basically like a film. It is going to, like a fabric. It is going to be used for wastewater. It is going to be used for wastewater as well as polluted air. So these porous membrane filters are made of aluminum oxide, zinc oxide, or they are really wonderful material which they are giving very good performance at the actual site. In the types, as I mentioned, you can see CNT carbon nanotubes are also highly flexible and light. Mechanically, CNT appear to be the strongest material we are using in our research. The smaller diameter has got stiffness, strongest fiber, the aspect ratio are very, very small. You can say 250 around. Carbon nanotubes are renowned for their numerous electrical properties and thermal conductivity both. You can see these multi-walled carbon nanotubes can be in different walls. It can protect you as a first stage of protection, second stage of clearing, third stage of cleaning. Like this, carbon nanotubes can be used. They are wonderful material. Apart from this, as I mentioned, there are many new areas, cosmetics, where the nanomaterial is being used without harming anybody's skin. Bioengineering is another area. Defense, as I mentioned you very clearly, that it is these Kevlars are being used for protecting our soldiers with some bullet and other things. This for Kevlar they are using this nanomaterial. Everywhere we have got nano devices, even optical engineering, nano biotechnology, medicine and drugs. I'll come to that later. Even energy also. There is a big demand to convert the solar energy to profitable energy in terms of, now we are using in our house to heat the water, no doubt about it. Some of them you are maybe using also even for converting it to power, but it is a very limited. The efficiency is hardly 8 to 12% only. as per the Solar Society of India, New Delhi. Okay, CSI. Now these nanomaterial can offer conversion up to 17% of the available energy. That is the latest research going on in the conversion of the solar power. In Tamil Nadu is very rich in the radiation of sun. Definitely, these materials can do wonderful thing to convert the solar radiations to even for wind farms also. The flexible blades can be devised without changing the rotation of the blade. I have seen windmills in the Kanyakumari area, Tuticorin area and all. Definitely, it is able to perform better. So they are really new areas of research in mobile application, in you can say road making, in the you can say cleaning a effluent from the textile industry, particularly in the Tirupur area. Okay, I think Pondicherry University is doing a lot of work. I have seen their website. They are doing wonderful work with the help of even they are using some biota to remove the effluents. Really great. Why I am telling all this to my students? There are many innovative applications are waiting for you to take up small project, maybe in Ooty, maybe in Coimbatore, maybe in say Trichapalli, anywhere. You can say you should be ready, fix on particular target, identify which is the nanomaterial, see its availability, and this. Actually, when I got my first project from Karnataka Council for Science and Technology, I got the nanomaterial from Andhra, somewhere near Rajamandri. He sent me. Now it's available in IAC only. There is no issue. Why I'm telling, they are available, but they are a bit costly. Some of them are okay, affordable. You may be thinking, sir is telling only qualitative tell. 1 gram will cost you around 3,000 rupees. Okay, titanium oxide. I'm just giving you an example. Right. As I mentioned, even this glass, can you see this right side on glass is there? This is a very old thing. I want to maintain its originality. I am going to give a nano coating on this. It can sustain even for 100 years. Textile, even you can see with very heavy rain in Bangalore, even under the raincoat, water will seep. We can have such material with the help of the nanomaterial. Even with a very high incidence of rainfall, water will not seep into raincoat. Okay, sports product, maybe the bat, maybe hockey stick, weapons, consumer electronics, whatever you name, it's available. And main thing is nanotechnology for structural monitoring. Recently, YAS was there in the Orissa area and Bengal area. I think our PM is visiting today. It has destroyed our property, maybe the bridges, maybe the farms, maybe the houses. We can include this structural material, we say mechanically induced material. We are going to use this for protecting under such high conditions of wind. Construction, I am coming to that construction later because I know my students are also watching. Solar application, as I mentioned. Environment engineering, water purification is a big challenge. Okay, even we can have a small nano filter. Suppose if I put a borewell in Bangalore, 1,000 feet I am going, and if I am getting it out, assume that it has got some small fluoride. Okay, assume that there are some carbonates. It's a hard water. I can have some nano filter, handmade or some man-made, small. Okay, like our earthen pot earlier we were using for cooling the water, no? Same thing. It can be used for filtering and removing, and it can be fit for using drinking. Fire protection is another area. Thanks to University of Science Bangalore, this is in their website. I have taken from them. Center for Nanoscience and Engineering is there. You can visit the institute site. They are doing wonderful thing. There is a cancer cell. I think it is very clear. It is now being identified, is adhered to the cancer cell, and it is going. It is a normal cell. It is not affecting this gentleman. It is going and is going to be detected. So we will be able to count the growth of the cancer cell in a body with the help of the nano detection. So these kind of things are, you can see here, nano motors, they say. It's like a carrier, nano motors, nano vehicle. for probing tumor microenvironment. Similarly, you can see, is the animation visible, sir? Nanotribology. Sir, Krishnamurthy, sir, madam?
Yes, sir. Please, sir.
Animation is visible, sir?
Yes, sir. Everything is visible, sir.
Thank you, sir.
Yes,
You can
visible,
see here, it's an animation in which assume that a cannon is coming and cannonball is striking our tank. You can see how the nanoparticles show the indentation in that. We can exactly mastermind our tanks to take care of these cannons. In the next one, you can see nanomaterial, rhodium oxide or titanium, it acts as a electrostatic precipitator. Is it visible? A smoke is going on from a chimney, maybe a boiler, maybe a thermal power plant. Okay, and you know very well, ash is a big problem. I can arrest this with the help of this nano electros. I should name it nano electrostatic precipitator, NESP. So, which is very, very useful. It can have an arrest efficiency up to 99%. Only 1% of the contamination will go from the, say, 10 kg per second it is going. Hardly you can say one very small 0.1 kg only it is throwing and dispersing. So, one more thing which I am showing as a absorbent. Can you see? Nanoparticle as a surface catalyst. If there is a contamination on a material, if there is a contamination on even, you can say, water or a contamination in soil, it can clean it. I can say nano cleaning. I will bombard this nanoparticle, which are very high in number, you know very well, and it will come out with by taking those contamination because of the surface tension force or the electrostatic force. So this is the advantage of this magic material which I am showing you. I am just showing you maybe few. I think its application is millions and thousands. One more thing, recently I think they have used this permeable reactive barrier. You might have seen, I don't know, you might have heard, this is water intrusion in the coastal areas of Karnataka or even in Tamil Nadu. The salt water is intruding to our aquifers. We can have a permeable reactive barrier under the ground and over the ground also. It will not allow that particular thing to penetrate this side and contaminate our system. Really fantastic. We can have even permeable reactive barrier of vegetation, which will not allow one particular fly to fly beyond that. Okay, you might have heard some flies came from Pakistan and they up to Maharashtra they came and they destroyed so many things. Still Bagalkot they reached and they destroyed our all standing crops and all. We can have such kind of nano barrier for them so that we cannot allow them to come. One more thing is deterioration of material. You know very well, if you see any old building, okay, it may be deteriorating with respect to time, maybe the cement, maybe the material, maybe the iron. We can stop it. We call it self-protection. I will come to that with a small video also. Innovative barrier material. It has got a very advantageous high surface area and its reactivity. Main thing is it is a dynamic in nature. Okay, it is dynamic in nature. We have static particles also, but it is dynamic in nature, both. Okay, so when we talk about types, we have a passive nanoparticle and active. I will come to that later. Similarly, in the mining areas, we can stop this heavy metal pollution to our aquifers, our vegetation. All this can be stopped. Groundwater can be made free from the contamination. Okay, even radioactive tracing is being done by CWRD in Calicut when I was in Kerala government. They are using some nanomaterial to trace whether the two rivers are interconnected, whether a pollutant is going from which position to which position. Say from Walayar area, if the industry is there on Kanjikode, if it is throwing a pollutant, I can trace exactly whether it is going to reach Coimbatore because of the interconnectivity. This kind of possibilities are there, right? I think I am making it very clear. You can say the carrier capacity of this is small particle. Okay, very nice. We in Hindi there is a say, जितनी छोटी होगी कीर्ति उतनी बड़ी, जितनी छोटी होगी मूर्ति उतनी बढ़ेगी कीर्ति. Same thing. This nanoparticle is choti murti, small idol, but it is doing big things. Permeable reactive barrier, I told no. Osmotic pressures, when they are using in the groundwater, it can used. Okay, this is a permeable reactive barrier which will filter a contaminated groundwater to a clean water. In the same well, we can have two partitions and you can extract good water. That possibility is also there. Central Government Board is also using this technology. I am coming to now nanoparticle of functional oxide nanomaterial. There are many oxides, maybe TiO2, maybe CuO2, AuO2, okay, or gold, silver, whatever you say, they are mainly finding more use in the battery. They are mainly used in our medical diagnosis. It is being used for LED lighting. It is used for, you can say, the fiber communication. It has very big application. Okay, my dear friends, we are now, I am saying that it's a very good area to do research. Okay, one of my earlier student has extracted activated carbon from the waste tea leaves. We make tea, tea, the leaf we will throw. He has taken the activated carbon, which can be used as an absorbent. Similarly, you should also do such things from the waste material, right, which is available. Use this nanomaterial to see that it gets a value. Okay, waste to health. It is there in tribology, even also polymer technology. It can, you can see this is small animation. Fantastic. Even honey bee, you might have heard all this bees. This can be used even for defense application. Nano in electronics, nanoparticle in flow applications, nanoparticle in measuring flow rate. Okay, we had a very typical project in Nanomaterials, Mangalore, where they wanted to measure the oil along with the iron fillings in that. They said, Nagara sir, can you suggest a magnetic flow meter or any flow meter? I suggested magnetic with nanoparticles in it. Definitely, okay, there is a Crone Marshall one company is there. They have given that particular meter around 8 lakhs or 10 lakhs, okay, for 600 mm pipeline, where you can measure it, the very accurate flow rate of an accuracy of 3%. Okay, so my dear friend, sorry, as I mentioned, sorry, yeah, nanoelectronics is another area. Carbon nanotubes. I don't know how much time sir is giving me now. It's 11:47. Right. Nanomaterials and concrete. I come to now my area where I am doing. I have done a small research. Application of nanoparticles in the cement-based materials. Basically, we would like to improve the mechanical property, resistance to crack, decrease in permeability. This is what our intention is. The first project was funded by Karnataka government, and we have used these materials to a small extent. Okay, I will show you the outcome of that. Nano concrete, structural composite, and we have a coatings also, as I mentioned in the earlier case. This is the way the things are going, in particular in concrete. Okay, it's a downloaded figure. Coarse aggregate, sand. Now we are talking about a nano silica. This is giving a lot of good strength. It is saving a lot of sand also. I need not take sand from Mother Kaveri or any river, right? Tambarvarani or any other river. I can say this. I can use this manufactured sand for performance, same performance. So this is a very good thing. We can engineer this nano sand for our concrete performance. Nanotechnology deals from size from 1 nanometer to 100 nanometer. We are using in our civil engineering. Nano modification, we say, we are seeing the improvement of concrete strength, its shrinkage behavior, its heat of hydration, impact resistance, and without pores also we can have cement now. So these are the materials we used: carbon nanotubes, microsilica, aluminum oxide, titanium oxide, zinc oxide, Advantages: more durability, more strength, less seepage, minimizing the cost, sustainable concept. Okay, sustainable means I am saving the nature. Silver nanoparticles, they are very costly. I have not tried this one. Zirconium oxide, they can be used in the concrete very safely, or with the cement very safely. As I mentioned, used in the project with varying proportions from the sponsored project by the Karnataka Science Council for Science and Technology, Bangalore. Now, when we have compared with conventional concrete, CC, then we have a CNS, then we have a CNA, all these different types, and you can see the proportion. Carbon nanotube also used 0.2% of weight. If I am using 1200 kg, I will take only 0.2% the carbon nanotubes and mix it thoroughly. Is it okay? In the cement, right? Let us see the photograph of this one. This is the different properties of cement. These are the things we used: nanosilica, aluminum oxide, carbon nanotubes, and nanosilica. So these things we used. They are very fine in nature. We have to be very careful when we are using this. We have to put mask. Now, unfortunately, because of the COVID, all are putting the mask, you know very well. But hand gloves and mask is compulsory. Okay. So, dear friends, I know that if you are going to do a small research also, you should maintain hand gloves and the mask when you are doing, and preferably a plain glass if you are not using specs like me. This is the small material. I think these are all my students who are working in the lab. These are the different strengths we have tested. This is our lab, and we have gone up to 2000 kilonewton to see the. Main thing you can see. I am again telling, normal concrete will be having a lot of whites, maybe 15%. With a nano concrete, I can make this 15% to 0, and the whole concrete block will behave like a single wall. I repeat, a normal concrete can have a porosity up to 15%, 10%. I can plug those 10% to 0 with the help of this great particle, and I can produce the strength to a great extent and with a high durability and less permeability. You know very well, when the rain comes, it will be permeable, slowly water will seep. It is not at all allowing. Not only that, it is thermally resistant. One of my PhD students is working on that, where we are increasing the performance of the concrete for high temperatures as well as high acoustic performance. It can absorb the sound waves also. Okay. These are the different data. I'm showing the graph just for your reference. What is the data? You can see with 3% nanosilica from 25 I have reached 43. What is the meaning of that? I am able to get high strength. Similarly, nano alumina is very good for the tensile strength. Alumina has got ductility, so it has given a very good ductile strength as expected. And thanks to my student, thanks to Karnataka government, this is the pattern of failure which we have seen. You can see up to 25 and 31, around, I think this much, 20% we are having increase in strength with a 0.3%, right? Similarly, we can see here also the carbon nanotubes. Very nice, up to 30% we are able to get the strength. Nano alumina, Na. Similarly, this is another material, microsilica. I can reach up to 42%, roughly you can say. From 25 I came up to 39. So it is also fairly good. Can you see this one? This is one company is there. Okay, and Zuari Cement. I don't know whether you heard this name. With the help of the nanoparticle, they are able to get a transparent wall. They are able to get a transparent wall with the nano optics. So this is another area where I am telling my students. I think they came to Bangalore in the exhibition. That time I talked to him. Then he gave me the photo of this. Okay, sir. Okay, you can show it to students. Apart from that, as I said, it is a very nice fire resistant. What is the advantage? It will conduct it so nicely. The heat dissipation or distribution or diffusion. I repeat, if there is a fire or if there is a hot environment, it is able to disperse the heat with the metal, with the concrete so nicely. It maintains the coolingness. So that's a really a wonderful wall we can create, wonderful house we can create with a nano material, which is can be having a cooling effect compared to normal house. This is the publication. I have not given, I think it's going to be published in next month only. It's in the elsewhere. Performance of nano material for the strength development in concrete as a partial at different temperatures. He is my PhD student from Jain University, Bangalore, HD Raghavendra Prasad. This is myself. So we are doing this work and we are also working on the acoustic signature also, right? Maybe I think next month, this next month it is going to be published. Now, I am almost coming to the end of my talk. One thing is very clear, whether it's electronics, whether it's a mechanical, whether it's a defense, whether it's a chemistry, whether it's a air, it's a soil, it's a water, everywhere the application is very high. Main advantage of this is it is able to have the photovoltaic in nature. It is able to combine nicely. It has got a very high surface area. It has got a mobility. It's a dynamic. Okay. In the agricultural area, I think nowadays my students are talking about IoT, Internet of Things. We are able to do lignin-based nano composites. NMKRV Bangalore is using such things. They are having they are using some fertilizers spray with the nowadays with the drones. They are doing, you know very well. It is having some nanoparticle which will not allow to develop one particular kind of bacteria. It is able to produce that environment. It is able to coat those things on the plant leaves.
தாவரங்களை அழிக்கிறதன் மூலமா இந்த உலகத்தை காப்பாற்ற இறைவன் தந்த வரம் தாவரம், அதான் நம்முடைய டார்கெட். அது எப்படிலாம் நம்ம உற்பத்தி பண்ண போறோம்.
Sir, somebody is talking. Okay. Even for the growth of the plant also, we can have this material in the medicine, as I mentioned, cancer, even for the COVID also they have used recently. There are many challenges are there. There are some challenges are also there in the case of nano material. Main challenge, I'll tell you, main challenge is the uniformity of the nanoparticle. Main thing is difficulty in synthesis and isolation. Some particles are very reactive in nature. They are thermodynamically unstable. Presence of impurities affect their performance a lot. No doubt, the quality we need to have a uniform. So it need to be, now I think we have IAC where these nanoparticles are being developed on a commercial scale. Okay, so we can overcome. There are two things which we call passive nanotechnology, which was there earlier. Passive means I am going to induce this particle as a coating, as a mixture, and it will give me a good strength. I repeat, passive means I am inducing this particle in the form of a coating, the form of a mixture. It is giving me a good strength. That's all. Okay, it is not doing anything else. But nowadays, active nanotechnology, where these materials, as you remember, it is called nanomotors, nano carriers, nano machines, like self-healing material. Example, if there is a damage in my aeroplane on the height of say 8 kilometers above the earth, it is able to repair it there and then. I'll show you one video. Is it available? Can you see the video, my friends? Can you see? There is a crack now, and this nanomaterial is going to now bring it back. We say self-healing structures. Is it visible, Krishnamurthy sir? Krishnamurthy sir, is it visible?
Yes, sir. Yes.
Yes, it is visible.
Thank you very much. You can see this is a wonderful material where you can see it is a help to the humanity. You have some problem at height of so and so, or even submarine under. Recently, our ONGC people struggled, you know, in that typhoon. I think we lost some lives. Maybe that material should have been, it should have not cracked. We can have this kind of thing develop with a timeline, maybe passive, maybe active, maybe hybrid, molecular nanosystem, magnetic nanoparticles also with resonance, with the orientation, spinning characteristics, all those things can be done, which is called evolution of nanostructures. Okay, those my friends from civil department or mechanical, I am telling you, it's a self-healing structure. It can be applied to a concrete, it can be applied to a metal. You have a bioconcrete, no, where the biological agents are there, they will correct. We have a nanoparticle which is going to correct your material or concrete. Is it okay? Now, I think I explained this too. Now, I'm just coming to the last. Just a minute. In the concluding, I would like to now conclude my session. The nanomaterials are plastic material. Okay, they are being used in road, nano GPS, geographical positioning system, asphalt road, self-healing asphalt roads are available now. Particularly CNT is doing wonders. Okay, recently we are doing one small project with my BE student at East Point College. We are using the bamboo using in the roads with the Karnataka government, and we are using waste plastic also in the region. But bamboo is giving very good flexibility to the pavement. Similarly, self-healing asphalt roads. So these things will reduce our maintenance cost. This will also see that some new technology is coming to our daily life. And whether concrete, whether it's a metal, whether it's a composite, whether it's a porous or a solid material, anything, definitely, whether it's a electrical performance, it's a battery, it's a earthquake, a flooding, agriculture, anywhere we can use with we can say definite surety, 100% surety. These are my references which I referred, and I thank the organizer for giving me a chance to share my small knowledge and to bring to my students notice that this is a wonderful area where one can explore the possibility of research at various levels. Okay, maybe at UG level, maybe at PG level, maybe in and PhD level also. It is going to have very good result, and you can have a lot of permutation combination also to see that your research is meaningful and reaches to society. So, with thanks to again Department of Physics, CSI College of Engineering, and thanks to all my friends who are looking to this lecture. Thank you, sir.
Professor Colin.
Fantastic, sir. Thank you for the fantastic and very informative session. You have touched almost all the areas, and it is very clear. It is very informative, highly technical, as well as it is very clear to all the participants. You have satisfied all the levels of the participants, high dignitaries to the students level. All of them are there, and it was very clear to everybody. So now I will hand over to Dr. Krishnamurthy for any further process.
Dear participants, I think so it was a wonderful lecture by Dr. Sitaram. If you have any queries regarding his talk and his field of research, please put in the chat box, or you can raise your hand so that you can submit your queries to Dr. Sitaram.
Doctor, I myself have a query. Yes, sir. Your transparent wall, really, it is a very great thing to see, sir. Can you just please explain on that if you have time? Please?
Actually, this transparent wall basically is a fiber characteristics of the nanoparticle, and it is the gold particles they used. Aram, they didn't tell me. I explored the possibility. It is the optical fiber nature of the nanoparticle which has put along with the cement. So it is That's why it's transparent. And he showed me one video also, but I unfortunately didn't give me the copy of that. Okay, how they manufactured it.
Thank you, sir.
Yes, participants, it's your time. You can submit your queries so that sir will answer your queries. Yes. Faculties, professors, students, please raise some questions.
One of the participants has posted, no query, sir. It was a very pleasant talk and informative.
No, my suggestion to my students is whether he's a science or engineering or any domain, agriculture, any area, this particular work has been is being done at IISc at a very high level. As I mentioned, instead of science, you can go to the Nano Center, and many areas are not explored. Maybe you can use some local problems to solve with this particle. Okay, you may be thinking, what is this local problem? I'll just tell you one small example. Okay, if there is a vehicle going on a road, and I'm a civil engineer, no, that will only think. A lot of dust particle will come, correct? And you sometimes, if you are on a road, you are going to put your handkerchief on the top. Okay, whether we can induce such material on the asphalt itself, it will give less dust. Even if it reduces by 10%, it is going to reduce the pollution level to a great extent. Okay, and when somebody was telling me, I don't know whether I'm correct, he's saying that, can we make our vehicle that whatever the metal is there, it can absorb some pollutants directly. Means if I'm going in Chennai road or Bangalore road, pollution is there, but my material, which is, I am in a car, I am in a truck, I am in a, you can say, bike, that material itself with the nanoparticle can absorb some NOx, SOx, SPM. So that way we can reduce the pollution. No, it's my imagination, maybe. So somebody can try such things. Okay, maybe RI may be trying, Automotive Research India, Pune.
So there's a question by Mr. Santosh. So what about the data acquisition using nanotechnology? Can you please share your inputs? That was his query.
Data acquisition is possible, particularly basically the normal data acquisition will not work with this, because these particles are so small. It is going to be counted exactly like bacteria. The density of the nanoparticles is being taken as a data acquisition. Okay, it cannot be counted exactly. So the density will be taken in particular area, and then it is being processed.
So there's another query by Mr. Niranjan. So what happens to the material when it breaks or gets repaired? It's a self-explanation. So how it is going to, what about the material when it undergoes a breakage or repair by itself?
Okay, it's a good question, really. You have seen that video, from that only the question has come. The material which is under a stress condition, okay, it gives up with one particular zone. Maybe it may be on the wings, or it may be in the tail, or in the nose of an aeroplane. Assume that. Okay, in that particular portion, the discontinuity happens. These nanoparticles are having a very high surface area. Surface tension forces are very high in nature, and they are also chemical in nature. So it starts acting immediately. I think, can I show that slide again? Just
Yes,
a minute.
please, sir.
I'll
Please,
go
sir.
back. Oh, sorry, it's gone out.
No, yes, yes, I think so.
It is there?
Yes, your Zoom is the presentation. Open the slide, sir.
Anyway, I'll explain to you. So those particles, definitely they will be acting, and they are able to survive under those extreme conditions at height. So because of the van der Waals forces, because of the surface tension forces in that particular thing, and the chemical recombination will take place. Okay, because wherever the portion is cracked, okay, it's hot or it may be cold. Immediately for that particular temperature, it is and again. So it comes back.
So how does the nanotechnology help us in just sorting out the leakages during the concrete during the rainfall seasons?
Yeah. Nanotechnology, particularly carbon nanotubes, are very good found for plugging the leakage. Okay, carbon nanotube with a single wall, not multi-wall. We have found in our own experiments which we are doing at Malnad Hassan, which is found that they are able to repel those water molecules whenever a high intensity of rainfall occurs on the surface of the particular concrete. So it is able to repel those moisture immediately by, exactly like we say this magnetic behavior, no, north will repel. That kind of nature is developing with that molecules of water, and it is able to protect the leakage.
Okay. So there's another question by Mr. Santosh. Can
sir, I have one question.
be controlled or programmed?
How?
Sir, I have one question.
Yes, sir. Please, sir. Please go on.
Sir.
Yes, sir. Please
sir,
carry
please
on.
tell me, sir.
Sir.
Yes, sir. Please carry on, sir.
Tell me, sir.
Sir.
I'm listening, sir.
Yes, sir. We could hear you.
Sir, can I ask you one question?
Sir, surely, sir.
Sir, myself, Basappa Mete. Hello, sir. Government engineer. Yes, thank you, sir. It is a wonderful session, sir. Really wonderful session. Which is nanomaterials is having applications in almost all engineering fields. Not only in civil engineering, mechanical, or electronics, somewhere else. It is having almost all the engineering field domain it has covered, sir. Sir, my one question or one doubt is that, as a hydrologist or hydraulic engineer, the application of nanomaterials in flood mitigations, can you explain, please, sir?
Flood mitigation is basically, sir, the flood will come when the overtopping of banks will occur, or you are releasing the, in that case, the demand of the day is whatever water is overflowing on the soil
Yes, sir.
should immediately get absorbed by soil. For example, if there is no rainfall for say 7-8 months, the moment you put small water, it is going to be sucked immediately. But if there is already water, soil moisture is there, it is going to retain on the top, right? So we need to make the soil with some nanomaterials so that it can accelerate the flow down the gravity, so and meet the nearby channels and all, so that it immediately get diverted. That is one method. Okay. The second method is second method is these nanoparticles. It can be used on the banks of the river. Okay, it can be used on the banks of the river where you can say it can, for example, if there is a Kaveri river, and you know very well it's only the earthen portion, and I know the zone of flooding. That particular zone of flooding, I am going to treat the soil with nanoparticle. So wherever there is a overtop in that particular area of Kaveri, the water is flushing very fast. So this is another way you can see the problem in a different way.
Yes, sir. Yeah, I think so. We stopped in the previous question by Mr. Santosh.
Sir,
can you repeat?
Can nanoparticles be controlled or programmed?
Yes, it can be controlled and programmed. Okay, definitely we can have that particular aspect ratio or the chemical characteristics we can build in. Anyway, I have not manufactured any material in my lifetime, but whichever companies are making, as I mentioned, IIC is making, or there is a Rajahmundry on Andhra on companies there. You need to tell the particle requirement. They will ask you what characteristics it should possess. And if you are very clear about that, you can even tell what is the environment it should sustain. So they will develop the particle for that and send it to you. But the only thing is, it is a bit costly as compared to other, as I mentioned, no, even 1 milligram will cost you 1,000 rupees.
So can soil erosion be controlled by the method of nanotechnology?
Soil erosion is basically, you can say, only controlled by plantation. All the roots are holding the soil. Okay, if there is no hair on my head, definitely even the rain particle will bombard me, right? Similarly, same concept applies here. But now question arises again, same, we have given the treatment of that particular area where the soil erosion is taking place. We need to arrest it. If you want to arrest it, we need some treatment, maybe LM treatment, maybe carbon treatment, or maybe nano treatment, where it will be having cohesive in nature, so that even if the water is trying to pull it, it will not flow. But check dams are the best, sir. As a civil engineer, I know check dams are the best. You can put check dams, okay, with nano boulders, you can say, so that it can arrest more and more soil. It will not allow the soil to flow towards sea.
Yes, sir. So there's a question by Mr. Chandru here. How can we make nanomaterials, or can we purchase them for the research purpose?
We have to purchase, sir. Making, I think I'm not sure. We have to purchase, sir. There are 2-3 good companies are there. I think one from Mumbai also, there is a manufacturer. And in IISc, definitely you can always request them. They themselves are researcher. So if you tell them, they will be able to give, sir. Purchasing is the best, sir, instead of making it. As my friend asked, can we engineer the nanomaterial? We can engineer, sir. But we should be very clear what is my objective. As my friend Meti asked, whether it can be used for flood control. Like that, we should give, and then we have to define the characteristics. Based on that, we can ask those companies. They will be working, but they may charge you something for that. But if you know one particular, maybe zirconium or carbon nanotube or nanosilica or anything, aurum also or silver also, they have some property. Even nano aluminum. A nano aluminum is very, very good, sir. It gives ductility property to the system. Asphalts, I don't know, road asphalt, they're using nano aluminum. Even CRRI is using, sir, Central Road Institute, Delhi.
Yes. Participants, any other questions? You can please raise. Participants, please. Yes, if there is no further queries, then I hand out the session to Professor Colin Grease for the vote of thanks and the closing prayer. Thank you, sir, for your wonderful speech once again.
Right, sir. I'll stop sharing now.
Thank you, sir. Thank you.
So it's my privilege to deliver this vote of thanks for this wonderful webinar. May I take this opportunity to thank Dr. Nagaraj Sitaram for the shower of knowledge for more than 1.5 hours and a very useful talk on nanomaterials and their applications in science and engineering. Sir, your speech is clustered with recent updates in nano field. No doubt that all the participants are benefited to a greater extent. Thank you once again, sir. It's
Thank you, madam. I want to tell you one more thing. I was earlier in Karaslingam College. Around we go Karaslingam, which is now Karaslingam University for 4 years. In Srivilliputturu.
Great, sir. Great, sir. Great, sir. So I thank our dear chairman, Right Reverend Timothy Ravindra, our correspondent, Mr. Sudhana Padre, and our dear principal, Dr. Joshua Gnanasekharan, for their continuous guidance. My special thanks are due to Mrs. Angeline Felicia, coordinator of PG studies. I thank the HODs of all the departments of our college for their constant support, and my colleagues for their constant support. I express my gratitude towards Professor Dan Prakash, Professor Praveen Balu, and Mr. Jerry for their technical support. It's my joy to thank all the participants via Zoom and YouTube Live for making this program a success in spite of some interruptions. I also thank the Almighty. I want to do the closing prayer and thank the Almighty. Father God, I thank you in the name of Jesus for enabling us to conduct this live webinar and make it possible. I pray that you bless our dear and respected speaker for his wonderful talk, and may this continue for years to come, and may his service of knowledge sharing to the society continue, and may many people be benefited as they were benefited before. I also pray for all the participants for your blessings on them. Thank you for taking full control of the program, and thank you for making it as a possible and a successful one. Thank you. In Jesus' name I pray. Amen.
Thank you, madam. Thank you.
Thank you
Mr.
all.
Kirti, sir.
Thank you all.
Thank you, madam. Thank you. Thank you.
Right,
Thank you,
sir.
sir. Thank you, sir. Thank you very much.
Hope to see you sometime.
Sure, sir. After this program, we'll meet,
God
sir.
only will decide when we are going
Yes.
to meet.
Sure, definitely, sir.
Thank you, sir.
Thank
Thank
you, sir.
Thank you very much, sir. Thanks very much.
Oh, thank you, Vasappa.
Sir, thank you, sir. Thank you. Sir. Wonderful session, sir. It is
Ah,
really
Thank you.
wonderful.
Right,
Sir.
right.
Thank you, sir.
Thank
Thank you, sir.
Thank you, sir. Okay, I'll leave, sir, with your permission.
Yes, sir. Please, sir. Thank you very much, sir. Thank you.
For all the registered participants, e-certificates will be issued. Thank you. Thank you for your patience and cooperation. Thank you.
Thank you all.